All right, this is our last section of conditional statements. We've gone I took one section, 2-3, and split it into 3 days. So it's little bits at a time to help you learn it at a slower pace. But the whole unit 2 is logical reasoning. It's not a lot of solving in here. So hopefully the whole thing will be easy. So first we did conditional statements. If P, then Q. And then we flipped it around to make them into converse statements where we changed the order. If Q, then P. Where P is the hypothesis and Q is the conclusion. So that hasn't changed. So we're starting off with a little bit of a review of what we've done this week. The conditional statement, so I always like to write the order of the letters. P, then Q is a conditional. The converse, Q, then P, and the biconditional is the special one. Biconditional is true both ways. P, then Q. All right, so the reason I do this by writing these letters out is for a reason. Let me tell you. If you map it out this way, your brain is only processing this tiny little bit of information at one time, the letters that match the words. And then whenever you start reading the problem and you start assigning P's and Q's to words, now your brain has to process which words you've attached the letters to and how they relate to these words over here. So if you map it out first in P's and Q's over here, once you start assigning the P's and Q's to the sentence, it's a lot less for your brain to have to do it once, so it's easier. So I would suggest you doing that as well whenever you work through these. Okay, so this is kind of a weird one. It's just a statement, lions are cats that roar. So I'm making lions, even though it's just one word, that is going to be my P. And I'm going to add some words because I can't just leave it as lions, if lions. That doesn't make sense. And cats that can roar is my Q. So that's my conclusion. So I'm going to write this as a conditional statement first, an if-then statement. So if it is a lion, which clearly I'm talking about an animal when I say it, but I'm just kind of making it short for notes. If it is a lion, then it is a cat that can roar. Okay, and now I've written a conditional statement, so I'm going to write a converse statement by changing the order. So if it is a cat that can roar, then it is a lion. Thank you very much. Awesome. Okay, so now I have a conditional statement, if P then Q, and a converse statement, if Q then P. If I want to write a biconditional statement, that means I have to have two true statements, a true conditional and a true converse. So I need to check my truth value. And to check truth value, the best way to do that is to try to come up with a counterexample. And if you can, then it's false. If it is a lion, then it is a cat that can roar. And whenever you're testing stuff out, you're trying to change the conclusion part. So if it is a lion, then it is a cat that can roar. Is there a kind of lion that cannot roar? No, I don't know of a species of lion that cannot roar. So this is true. All right, so now we're going to check the converse. If it is a cat that can roar, then it is a lion. So we're changing on the lion part. If it's a cat then roar, could it be anything other than a lion? Yes, of course. So this is false. The counterexample, it could be a tiger. Or a jaguar. or all kinds of other cats, right? So then I can't write a biconditional, so I'm going to write NA, that means not applicable. I can't do it because the converse was false. So converse was false. You can only write a biconditional if both the conditional and the converse are true. So again, that was a review of what we did over the last 2 days. Next, this isn't a type of statement, this is just negation. Negation is a concept, and we're looking at the symbol in front of P right here. It has a little squiggly line that's called a tilde, and it means not. So you read it, that symbol, and P is read as not P. Negation has the opposite truth value. So if you take a true statement, throw in the word not, it becomes false. You take a false statement, throw in the word not, it becomes true. So we're going to start off there, and then we're going to have negation in our statements. All right, so for example, so these are not conditional statements. These are just plain statements. Houston is the capital of Texas. Truth value, is it true or false?
False.
False. It's not true. So the negation is Houston is not the capital of Texas. And that is true. So it has the opposite truth value. Because we didn't change any of the words in the statement. We just added the word not. That's it. And that's a negation. So next up is an angle with a measure of 90 degrees is acute. Is that true or false? That is false. Because a measure of 90 degrees makes it a right angle. So the negation, same words, we're just adding the word not. An angle with a measure of 90 degrees is not acute. So we're not changing it to be a right. We're using the word not, and that's it. And that makes this true. Because if it has 90 degrees, it is not acute. All right, so that's how you use negation. And I really should have had on here, it's say conditional. P, then Q. So we can see all of the conditional statements at once, because now you have 2 new ones. There is a 5th type of statement we've already talked about called biconditional. It's not on here because that's not an if-then. These are the 4 if-then statements: conditional, converse, inverse, and contrapositive. So inverse and contrapositive are the 2 new ones today. Inverse is like a conditional if P then Q, but it's not P and not Q. So inverse is not, not. Inverse, not P, not Q. And the inverse of the conditional statement negates both the hypothesis and the conclusion. So that symbol for the word not is in front of the P and the Q. So you're using the word not 2 times, just like in the letters. And then the contrapositive does both. Like the converse, which is the order. The inverse adds the word not. The contrapositive does both. It changes the order and adds the word not. So the long word does both. It switches the hypothesis and conclusion and negates both. So, again, we have P, just so you can follow it along. P then Q, Q then P. Not P, then not Q, not Q, then not P. So conditional and inverse have the same order. One's just negated. Converse and contrapositive have the same order, but one's just negated. All right, so we have 2 examples. We're going to write the converse, the inverse, the contrapositive of the conditional statement, and then find the truth value of each. So again, I'm going to write what I'm dealing with. I have the conditional statement, if P then Q. I'm going to write a converse, if Q then P, and then I'm going to write the negations of them. So going back to the original order, not P, then not Q, and flip it again, not Q, then not P. Okay. So first we're going to identify P and Q. If is the signal word that tells me that P is right after it. If the measure of angle A is 95 degrees, then angle A is obtuse. And real quick, the reason why these two symbols are different, the little M in front of angle A stands for measure. So it's only there whenever it's talking about the size of it in degrees. So the measure of angle A is 95 degrees because it's talking about the measure in degrees. The other one says angle A is obtuse. There's no M there because it's not talking about the size of the angle other than classifying it as obtuse. So it's like an object over here. That's just a side note for later whenever we get into angles. It just helps to hear it more than once. So the converse is going to be if Q then P. So if angle A is obtuse, then the measure of angle A equals 95 degrees. All right, so we were given a conditional. We wrote the converse. Now we're going to write the inverse. So we're going back to the original order, but using the word not. So if the measure of angle A does not equal 95 degrees, so I just put a line through the equal sign, and that means not equal, then angle A is not obtuse. So we're simply adding nots into both. And then contrapositive, we're going back to the converse order and negating it. So if angle A is not obtuse, then the measure of angle A does not equal 95 degrees. Okay, so now we've written all four statements, and we need to decide the truth value of each. The way to decide the truth value is to try to come up with a counterexample. So the first one, if the measure of angle A equals 95 degrees, then angle A is obtuse. So we're going to leave the first part the same and try to change the second part to something else and see if it works. So if the measure of angle A is 95 degrees, then angle A is acute? No, that doesn't make sense. Is right? That doesn't make sense. Straight? No. So the only thing it could be is obtuse, and so this is true. There's no counterexample for this one. So that's true. All right, so let's try with converse. Check the truth value of the converse. If angle A is obtuse, then the measure of angle A is 95 degrees. So we're going to leave the first part the same. If angle A is obtuse, and then we're going to fill in something else for the second part. Then the measure of angle A is there anything else we can fill in for 95 degrees? 91 degrees, sure. So if angle A is obtuse, then the measure of angle A could be 91 degrees, and it would still be obtuse, right? So that means this is false. It doesn't have to be just 95. There's anywhere between 90 and 180 degrees makes this a true statement, so this is false. Our counterexample was 91 degrees. Okay, so inverse. Now we get to check that one. If the measure of angle A is not equal to 95 degrees, then angle A is not obtuse. Okay, so we're going to change up the second part. If the measure of angle A does not equal 95 degrees, then angle A is not acute. Well, we don't know, right? There's not really enough information. Is it, so if it's not 95 degree, okay, so we're going to have to change the first part. Normally it works changing the second part. What if we made it 100 degrees, because that would not be 95 degrees. So if the measure of angle A is 100 degrees, then angle A is not obtuse. Does that make sense? It doesn't, because it would be obtuse, right? All right, so this is also false. All right, so then the contrapositive, if angle A is not obtuse, then the measure of angle A is not 95 degrees. Well, that's true, because if it was 95 degrees, then it would be obtuse, right? So if it's not obtuse, then it's not 95. We're not talking about what it is, it's just not 95. So this is true. All right, so you can see that the truth value of the conditional has the same truth, or the opposite truth value as the inverse. So those two are in the same order, P then Q, P then Q, but the inverse is negated, so the truth value changed. And then the same with the converse and the contrapositive. Their truth values changed with the not. Now, of course, it's not as simple as all that where that's always the case. So that's why there's a second example. So this is when the conditional and the converse do not have the same truth value, then it matches in this order. Conditional goes with inverse, converse goes with contrapositive as far as truth values. All right, so let's look at the next one. All right, so if a polygon is a triangle, then it has three sides. That's the conditional. That's the P, then Q, the conditional. We know converse is when we change the order. Inverse is the original order, but negated. Not P, then not Q. Contrapositive is switch the order and negate. Not Q, not P. Okay, so if a polygon is a triangle, then it has three sides. So then the converse is if it has three sides, then it is a triangle. Kind of shortened it a little bit just for the sake of writing. Turned polygon into it. Okay, so there's the converse. So inverse goes back to the original order, P then Q, but with negation. That means if it is not a triangle, or if a polygon is not a triangle, then it does not have three sides. Okay, so then the contrapositive, flipping the order and negating. If it does not have three sides, then it is not a triangle. Okay, so I have all 4 statements written, all 4 if-then statements. So I need to check the truth value of each. If a polygon is a triangle, then it has 3 sides. If a polygon is a triangle, then it has 5 sides? That wouldn't work. Is there another number we could plug in that would make this true? I mean, false? No. So this is true. It's a true statement. If a polygon is a triangle, then it has 3 sides. What about the converse? If it has 3 sides, then a polygon is a triangle. Well, if it has 3 sides, are you going to call it something else? Are we going to call it a pentagon? No. Quadrilateral? No. No, we're going to call it a triangle, so there's no other word. So that is true. So both the conditional and the converse are true. Well, then the negations should be changing the truth value. If it is not a triangle, then it does not have 3 sides. That is true. If it's not a triangle, then it does, because if it had 3 sides, then it would be a triangle. So this is also true. So the negation didn't work. We have a special case. One more, the contrapositive. If it does not have 3 sides, then it is not a triangle. That's true. If it has any other number of sides, it's going to have a different name. So these are all true. And the reason the negation did not work on this is because this is that special situation where we could write this as a biconditional. Because this is actually a really good definition of triangle. If a polygon is a triangle, then it has 3 sides. So the biconditional would be a polygon is a triangle if and only if, which I'm going to abbreviate with IFF, if and only if it has 3 sides. All right, so that's another example of when the conditional and the converse have the same truth value, you can write a biconditional statement. And even negating it is not going to change the truth value. But any other time, whenever the conditional and the converse do not have the same truth value, when you negate them, they change values.